Alright, so in this next part right here, we're going to determine if the conditional statement's true, then we're going to write the converse, inverse, contrapositive, and determine if those statements are true or false. Alright, so this might be a good time to pause the video. Maybe you can try this by yourself, do all these statements, and then you can just check your work, or you can stay tuned. Anyways, we're going to notice a pattern here. Logically equivalent statements, so like whether it's a converse, inverse, contrapositive, conditional statement, there's going to be a pattern where some are always true, some are false, or whatever that may be. Alright, so if you have Mr. Oswald, then you go to Darby High School. That is a true statement. I don't teach anywhere else. Alright, so converse, remember swap order, putting your Converse shoes on the wrong feet. So if you go to Darby, then you have Mr. Oz. Alright, that is unfortunately a false statement. Alright, I would love to teach every person that attends Darby High School, but I don't. You might have friends that took a different math class and they don't have me. But if you go to Darby, then you have Mr. Oswald is a false statement. I do not teach every student. Alright, so inverse, negate. Or inverse, not. So remember, order stays the same if you don't have Mr. Oz, then you don't go to Darby. Alright, this is also false. We forgot to do a counterexample, but we'll put everyone's favorite math teacher. Maybe you had Mr. Miller. Alright, I know a lot of you guys had Mr. Miller. Or maybe you had Mr. Kistner, Mrs. Maddox, maybe you have some friends that have Mr. Zodi, whatever the case may be. And then contrapositive, most work. Most letters, most work, you're doing both converse and inverse. So, if you don't go to Darby, then you don't have Mr. Oz. My handwriting got a little sloppy. I was just really excited, went a little too fast. If you don't go to Darby, then you don't have Mr. Oz. So notice how I swapped the order and negated. This is a true statement. Alright, if you go to like Davidson, you're not gonna have me. If you go to Bradley, you're not going to have me. Alright? So if you don't go to Darby, then you don't have Mr. Oz. Alright? So, just cruising right along. If two angles add up to 90 degrees, then they are complementary. That's true. 90 degrees, complementary. We've learned that. In fact, I think I spelled complementary wrong in this. It's actually with an E. Oops. But anyways, converse. Let's do this in purple. Let's mix up the colors a little bit. Right? If two angles are complementary, then they add to 90 degrees. Alright? So remember, we just swapped the order there. Add to 90 degrees. The hypothesis went to the back. The conclusion went to the front. Alright, if two angles are complementary, then they add to 90 degrees. That's true. Alright, now inverse, we're going to negate. So same order. If two angles don't add to 90 degrees, then they are not complementary. All right, so same order. 90 degrees was in the front, complementary was in the back. However, I put the nots or don'ts, whatever you want to call it. However, is this true or false? If two angles don't add to 90 degrees, that means they add to something else. So that means that they're not complementary. We'd call them something else. So that's also true. Interesting. All right. And then contrapositive. So most letters, most work, we got to do both inverse and converse. So if two angles are not complementary, then they don't. I have to organize my work here really poorly. Add to 90 degrees. All right. And just to emphasize things, sorry I was really sloppy there. If two angles are not complementary, so complementary came to the front, 90 degrees went to the back, so we swapped the order and we put the knots. All right, so they're not complementary, so they don't add to 90 degrees, and that is also true. All right, so we just saw a case where it was all trues. My handwriting's a little sloppy. Good thing I'm not an English teacher. All right, but don't ask your English teacher to do math. That'd probably go horribly. All right, so there is a pattern going on. You guys might have figured out the pattern already. Maybe not. Hopefully after this last case we do. If two angles are adjacent, then they form a linear pair. This is unfortunately a false statement. Linear pairs are adjacent, but just because they're adjacent doesn't mean they form a linear pair. And here's a counter example down here. I'm just going to draw two adjacent angles. This doesn't add up to 180 degrees. So remember, linear pairs have to be supplementary. They have to equal 180 degrees. So that's false. All right, now let's cruise right along this one and then see if we notice the pattern. Converse, if two angles form a linear pair, then they are adjacent. All right, it swapped the order, and this is actually true. If angles form a linear pair, they have to be adjacent. Absolutely, that's part of the definition of a linear pair. Now we're going to negate it. If two angles aren't adjacent, then they don't form, I'm going to put LP because I kind of ran out of room. Again, maybe I should have typed this out, but oh well. You guys get to see my beautiful handwriting. And that is a true statement. If they aren't adjacent, if two angles aren't adjacent, there's no way they can form a linear pair. And then last one, the contrapositive. So most letters, most work. If two angles don't form a linear pair, again I'm just going to put LP, then they are not adjacent. All right, so they don't form a linear pair, so they're not adjacent. We can have adjacent angles that aren't linear pairs. That's totally fine. So this one's also false, and it's the same counter example as that we already drew. All right. So did we notice a pattern? Hopefully you did. This is the pattern right here. Are you guys ready for the pattern? Drum roll, please. All right. If the conditional whatever the conditional statement is, the contrapositive has the same truth value. True, 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 or even false, false. All right, the conditional statement and the contrapositive always have the same truth value. They're logically equivalent. So that's very interesting. If you take a conditional statement, an if-then statement, swap the order and negate it, it's still going to be true or it's still going to be false. I don't know about you guys, but I find that really interesting. All right? So if a conditional statement's true, then its contrapositive is also true. All right? Similarly, whatever the converse is, the inverse will be as well. All right, so here's two cases where they were true, true, or even false, false. All right, but they always have to be the same as well. To me, in all seriousness, I find that really interesting. All right, and these are logically equivalent statements. All right, whew. All right, that was some beast of some work right there. All right, we're getting really good at this stuff. One last video, couple problems, then you get to do some problems on yourself.